What is up, YouTube? Let's learn about how APIs interacting with different domains use cross-origin resource sharing, otherwise known as CORS. CORS is something that a lot of full-stack developers run into when they're trying to set up a website that hits a backend, and they usually run into this issue, and this video will talk about what that actually is and how to get rid of it. Let's get into it. So let's do a quick background on CORS. With the introduction of JavaScript and document object model in web browsers, manipulating an HTML's documents, objects, and properties using JavaScript became possible. As a result, malicious scripts loaded by one web page could interact with the resources of another web page and retrieve sensitive information using the latter's DOM. This vulnerability of the DOM could be exploited by forgery attacks, such as a cross-site request forgery attack, where a malicious request is forged to make it look like it's been made by a legitimate user, which is used to gain access to private data and perform malicious actions. And through this, attackers could gain unauthorized access to different resources. So here's an example scenario. John is lured into visiting evilsite.com, and this site responds with a JavaScript code that then makes a call to facebook.com where John is already logged in. The JavaScript code downloaded from evilsite.com obtains access to the DOM elements of facebook.com and by virtue to John's sensitive data. So let's talk about the origin problem. The example that we saw demonstrates an unrestricted interaction between two web pages belonging to different origins, which could lead to a data breach. An origin is defined as a combination of the scheme, the host name, and the port number, if it's specified. And two URLs are said to have the same origin if and only if they have the same schemes, host names, and port numbers. And URLs with different host names belong to different origins. A request that spans across different origins is known as a cross-origin request. Now let's talk about the same origin policy, otherwise known as SOP. To combat this susceptibility and reduce attacks, the engineers at Netscape defined a rule called the same origin policy, which is where two web pages can only interact with each other if they belong to the same origin. Simply put, the URL evilsite.com can't access the resources of facebook.com since they both have different origins. The illustration depicts a same origin request. So since the origin of the web document and the requested image are abc.com, the request will be successful. If a server only allows requests from its origin, it follows the same origin policy. So let's talk about the cross-origin resource sharing, otherwise known as CORS policy. In today's world, it isn't feasible not to allow requests from other origins. The SOP is too restrictive, so we need a method that relaxes the constraints imposed by the single origin policy. One such technique is the cross-origin resource sharing, otherwise known as CORS, which allows websites to bypass the single origin policy by going through checks. CORS employs an HTTP header-based mechanism to inform the web browser whether an application belonging to one origin can access resources from a server at a different origin. So CORS allows two types of cross-origin requests. There's simple and pre-flighted. Let's begin with the simple requests. So let's talk about simple requests. A simple request meets all the following conditions. So firstly, the request must have an HTTP method, and these methods that are included are get, post, and head. And secondly, the request should have headers that can be defined manually in header variables. So the allowed variables are accept language, and content type and range. And third, the only allowed values for content type headers should be defined in the requests. So the allowed values for that are application, form, URL encoded, multi-part form data, or text plain. And fourth, the upload request object has no registered event listeners. And fifth, no readable stream object is used in the request. So readable streams are a stream of bytes that are utilized in operations where data is read. Examples of such operations are file reading or video streaming. So the process for simple requests begins with a cross-origin request initiated by abc.com for data that is stored in xyz.com. And while abc.com is a web service in our context, it will act as the client, and the request contains the client's origin, which is abc.com. And a response is then sent from the server to the browser, and the server adds an access control allow origin header to the response, which has abc.com in it, right? And then the browser then compares the origin in the client's request with the access control allow origin in the server's response. And if they're identical, the cross origin request is permitted by the browser, right? So the browser will compare the two and accept that request. And the application origin abc.com is present in the server's access control allow origin header, which means the cross origin request will be approved. So here's what the CORS request would look like. So here we have our GET request, and we're trying to hit the XYZ server, and we're coming from the origin of abc.com. And the server may send the following response to the request from before. So here we have a 200 status code, and we have abc.com in our access control allow origin header, and then we have the rest of the response, right? Since it was approved. And because the origin header in the request and the access control allow origin header in the response match, the request will be approved. And in comparison, let's look at a server response where an origin is not allowed to access the resource. So here we have a 403, and in our access control allow origin, we don't have abc.com, we have this other domain.com, right? And in this case, the origin and access control allow origin headers don't match, therefore the request will not be approved. The browser won't allow the data to be shared with the client, and this results in an error on the client side. So is there a way to allow cross-origin requests from all the origins? Yes, actually, in very specific cases, the access control allow origin header may be set to a star, which allows any origin to make the request. This is also known as a wildcard. This cannot be allowed in the real world because of security issues that will arise if private data is shared, and because most browsers don't support this wildcard. Now let's talk about pre-flight requests. If a request doesn't fulfill the conditions for a simple request, it needs to be pre-flighted. This protocol was given this name because it functions similarly to how passengers must be pre-flighted before they can onboard the plane. Pre-flighting our requests include an initial check, which ensures the request is safe to be sent to the server. So the check would be as follows. The browser already knows what requests to pre-flight and makes an initial request to the server seeking permission to employ the methods. This is done through the options method, which specifies the client's origin, and access control request method. This is known as a pre-flight call. So in our request, we have our options method. We're trying to hit xyz.com. Our origin is abc.com, and we are trying to access the post method. And then if the server accepts the options request, it responds by allowing the client to make requests with the method they requested. These methods are specified in the access control allow method header, and the response header by the server may look something like this. So here we have a 200 response code, and in our access control allow origin, the server is allowing abc.com, which is good for us, and they're allowing the methods of post, get, and options, which is also good for us. And after the successful completion of the pre-flight check, the CORS request can be sent by the client abc.com as before. This time, the client is allowed to define custom headers or use other defined values for different headers. In this case, the client could set the content type header to be application XML. So in our request, our host is xyz.com, which we're trying to hit. Our content type is XML, and our origin is abc.com. The server then responds to the CORS requests as it normally would. Note that to prevent further overhead in our API, we can cache the preflight for a certain amount of time to prevent unnecessary server requests, which could lead to a potential bottleneck. This means multiple requests can be made to the API in the specified time frame. This is provided in the access control max age header that's provided by the server, which stores the maximum time the request can be cached for. So let's talk about authentication and pre-flight requests. By default, both simple and pre-flight requests don't include authentication through credentials. This can be added by the authorization header in the request or take the form of an authorization cookie. To enable this, we must manually specify the flag with credentials to be true for the request. The access control allow credentials header in the server's response must also be set as true. Authentication with an authorization cookie is shown below. So our server sends this access control allow credentials to be true, and then our client has a cookie. So CORS vulnerabilities. Even though many APIs and applications implement CORS to allow communications and access from third parties, vulnerabilities may arise. They typically stem from the lackluster implementation of CORS without taking the proper security measures. Some major factors that lead to CORS being vulnerable are given below. So there's third-party verification for clients who use the APIs is not strict enough. So many APIs may ease their verification to ensure everything functions, which allows attackers to exploit this lack of scrutiny. And APIs allow access from any other origin, and this allows malicious origins to access the sensitive resources in the API. If an API that is susceptible to injection attacks trusts an origin, so an attacker could inject malicious code that utilizes CORS to gain access to sensitive information. So, prevention of vulnerabilities. Almost all of these vulnerabilities stem from the incorrect implementation of CORS. If we're stringent when we implement CORS in our applications, we should avoid most problems. This can be done in the following ways. So first, stringent verification of all origins. There's a direct correlation between an API's leniency in checking origins and the exploitations that may occur. Second, only allow listed and trusted origins and avoid access to all subdomains of an entity because attackers may exploit this. Third, avoid using wildcards on networks, sites, and URLs. A list of trusted origins should be maintained even if it increases the complexity of the implementation. And fourth, server-side validation should still be implemented. CORS isn't a substitute for this validation. In terms of API security, CORS is a robust option because often most of our requests are from external sources. It's flexible and it allows options for security, such as the wildcard and pre-flighting requests. So let's do a quick quiz. The HTTP delete request will need to be pre-flighted. So there are two types of requests. There's simple and pre-flighted. If it's not simple, it will have to be pre-flighted. If it's a CORS request, right? And so for it to be simple, the allowed methods are get, post, and head. And since delete doesn't fall into any of these requests, it will have to be pre-flighted. So the answer is A, true. And for the second question, a cross-origin request is when a website requests data from its own domain. The answer to this is false because cross-origin is when it requests data from a different domain, and a same origin request would be when a website requests data from its own domain. So the answer is false. And lastly, the access control allow origin equals star allows for specific origins to make a request. Well, when you set the access control allow origin to star, this is a wildcard and allows any origin to make a request. So the answer to this is false. Thanks so much for watching. This is definitely an issue I've run into many times in my career. I never really understood what it was until recently, and hopefully you learned something. If you like this video, then leave a like and subscribe. If you have any questions, leave a comment, and I'll see you in the next one.